Hello, before we start the logic gate, exactly how do they function, let's know about the history and the evolution of the logic gates. So, first of all, from they are saying that theory to silicon means how the exact concept came out, and the theory people must have written it, and then finally they have brought it to the silicon means actually it is referring to the chip. All right, so let's see that what was the time reached those time. It was almost 1800s and 1900, and then two people, one name is Charles Pierce and another is a Nikola Tesla. The Tesla name actually you must be aware. All right, so these two people, how they thought of it, they proved actually. The Charles proved that logic could be replicated. Replicate means they can, if they have created one Boolean logic uh, pattern, so they can create it as it is ditto. So replicated means making a copy of any logic as it is with electrical circuits. And then they said that, and afterwards then they came to know about the Norgate University. All right, then next name is the Nikola Tesla. He patented logical and circuits for signal processing. Okay, mostly he was working on the wireless remote system, so he thought that it can be utilized for the signal purpose. Then finally, according to the books, mainly the computer student, they come to know about this Claude Shannon in 1937. So he has gave the concept that in computers also we can apply the same thing, especially so like in MIT means it is the Massachusetts Institutes. All right, it is they have written the thesis. They have connected the Boolean algebra. So Boolean algebra means once they conclude something in true and false means or in one or zero. So they said that they can electrical switching circuits they can design in this way. All right, so they gave this concept in the MIT thesis, and then they created the series of switches. Especially they made AND gate, which was the series, okay, continuously after one and second and third and like that. But afterward that they utilized the parallel switches also. In the parallel switches, what they did, they use OR gates. So about these gates, we will learn, and with the help of a simulator, how the signals are evaluated. But before that, we should know about this concept also. Then afterward, phase A comes where mechanical relays in 1940s. Okay, phase A comes. So where they especially focus on the mechanical. Then in same soon in the 1941, after that some duration of the gap, the Z3 computers. Okay, Conard Zoo programmable. It was programmable and programmable plus digital computer. And in this almost it is general calculation you can see, the 2000 mechanical relays were used. All right, and then phase B comes where vacuum tubes were utilized. After that, in 1945, ENIAC computer everybody knows very well that it was the first general purpose electronic computer, and in this 17,000 tubes were used. All right, and high speed logic gates. Why? Because of course it was specially for the means when in the beginning that ENAC and the UNIVAC they were constructed, it was specially for the calculation purpose. All right, so they required logic gates. Now let's come to the modern era. All right, let's come to the modern era, and in this, okay, in this, if we come to know that especially they have taken for this modern era in the especially the transistor. Actually, transistor vacuum tubes, when they were used, the computer size were quite big. But now in future, they decided that computer should be miniature as much as possible. That's why in our hand, smartphones are there and laptop in a very small, and then whole CPU. You see how it is, made into the small size. So especially the Bell Labs, where they invented of the transistor and efficient semiconductor switches. And then they come to the microchips. IC means integrated circuit, means where multiple circuit this microchips were there, and then they were integrated and brought into the small scale. All right, so you can see that afterwards means a particular board was there. You can say the whatever is the motherboard design was there. So they integrated billions of transistor gates on silicon wafers. Silicon wafers means a material which is especially used for designing this microchips. IC integrated circuits means multiple circuits were brought together into one uh, this board. All right. Afterwards, modern CPU and smartphones, you know very well. So this was the all history. All right. Now afterwards, we will come to the. This was the history. So you just remember it. Okay. So this was the history and evolution of logic gates, that how it came into the light. All right. So a little bit knowing theory is not a a loss. You should know it. Now we'll come to the simulator. We'll go to the simulator, that how signal work. What are those signals? Okay, binary number if you have learned, so it will be not difficult for you. And even if you know about the binary division, addition, and these all calculation you have already done, so logic gates will be easy to understand. Right. So let's see again. Now you can see in front of you a kind of simulator is there. All right. I'll present the table also, but before that, let's see even in exam if you want to draw. Of course, this is the way how we can draw. Okay, this is the A and B. Okay, here how we show the signal. This is the A and B, and this is the AND gate. This is the way how we draw AND gate, and then you can see that when both the signals are evaluated, then a single output will be there. Here you can see one, this is A input and this is the B input, and finally what will be the output once it is evaluated. All right, so we can see that this is the combination, right? This is the combination. So this is the way how we draw. This is the diagrammatical way, and sometimes it is the truth table way, where it is input A and B is written, and then how it is um, calculated. Now you can see the first of all what we have done, that gate type. Okay, gate type means we have taken AND gate, and this time input A and input B both is in the low state. Okay, so low state means this is called 0. If high state means it will be as the 1. So drawing this gate will be not very difficult. Reason is that every time you have to show that A and B, that is the, for example, this time it is in the low state and there is no output. Actually means the low signal means low output also. Now especially we'll focus on the, especially this your truth table. All right, this truth table is very very important. And then binary is still in the binary form. Okay, so if it is in 1, it means that it is the binary high value. You can say the high state, and if it is the binary 0, it means it is the low value. All right, so let's see. First of all, gate type I have selected and this time input is like this. It means, for the example, it is 0 and 0, so output is also 0. If I will try to help you, do you know, take it as the multiplication. Yes, and get you take it as the multiplication, means 0 into 0 is 0, 0 into 1 is 0, and 1 into 0 is 0, and 1 into 1 will be 1. So this is a trick magic you can remember in this way. This is the way you take this gate in this way. So let's try another. For example, if I go for the second state means if input becomes 1, if input becomes 1, okay, or you can say if both becomes 1, then what happens? You can see that 1 and 1, then finally it is 1. Okay, like if one input, like you can see automatically it is switching to that. If input is low, okay, if input A is, it is the 0 and second input is 1, so it has gone in this state, right? Now what we want, that if input 1, all right, is like this and another input is in the this low state, so you can say high state and the low state. So what is that low state? So you have already seen that in three condition the output is in the low state. Why? Because any one it means is if any one of the signal will be in the low state, then output will be in the low state. So for that, if we want the output in the high state, it means in the binary form, means both the signal should be in the high state. This was about your AND gate. Okay, after the AND gate we will come to that uh, OR gate. OR gate you can take as the condition you can say in any one of the bit, like this. Or means any one of the two. So I'll go here and select that or. Okay, and in this or, what happened in and, two input were required. So in the or gate also we need two input, means one A and one is B. All right. So let's see how its diagram will be there. So see, it diagram is changed now. Okay, it has gone inside, and this is the symbol. Okay, two input signal line. Okay, and then this is the gate symbol, and then finally output signal line. So this is the way how we draw the OR gate picture. Okay, this is the diagram for that. All right. So let's come back again to the truth table and then evaluation. Now what we can see here, all right, what we can see here, that in the OR gate, if any one of the signal, if any one of the signal, okay, if any one of the signal is in the high state, so it will treat the answer as a high state only. You can see in the very first row, both the signal is in the low condition, so you can see the output is also in low state. It means the signal is zero, you can see. Now if I come to this one, okay, if I come, means one is low state, means it is 0, and then high state, it means it is 1. So you can see now this is the condition. So or means any one. If any one is in the high state, it will take the high state. All right, that is the high signal, you can see. Fine. And now in this, okay, fine. So all right, and then third condition means one signal is in high state and second signal is in the low state. So, but as the condition says, if any one of them will be in high state, we will accept the high state. So you can see the output. And last one is easy because both are in high state. Okay, so student, again, please see this. In previous one, when we were evaluating the AND gate, in that what happened, it was a compulsion on both the signal, okay, on both the signal to be in the high state. But here the condition is just, we can say, almost it is happening like that, giving more freedom. Okay, it means if any one of the signal is in the high state, so it is evaluating is as the high state. Now we will go to the not. Okay, we will go to the not. Now in the not, what happened in the no? So because of course it is just the, you can say, inward. Okay, you can say it is the inward way. Inward means just opposite. Okay, whatever the answer will be there, it will means. And let's see that how it is. You can see this is the way. If the input is 1, okay, if I give the input 1, so it will just make it opposite, means that it will take the output as 0. Okay, it will invert the signal, it will make the signal opposite. So this is the way how it is doing. Okay, so let's see if, and you can see here input A. Fine. So input B is not there, that column, so it will not work. For example, if I take in the low state, okay, if I take in the low state, now you see what happened. Okay, how the signal is taking that. If I take input as a 0, so it is just opposite of the low state. Okay, now it is the high state. So this was your all gate. All right, all gate. So remember it, you revise it. I will not means combine all the gates together. Other gates are also there, like XOR, NOR. Okay, and so in next video you just wait it, so where I will combine all the gates. So now this much, okay, this much you can revise. And one more suggestion is there, you try to take multiple inputs. Multiple inputs means make sure, if input A instead of input B and input C means more input, if it comes, make, just imagine if the 3, okay, just imagine like 3 input. Now here I have just taken the, let's extend it. For example, I have just extended that, especially the AND gate. Okay, so it is saying if you take 3 inputs, then you have to follow the same fundamental rule, okay, as you tried with the standard 2 input gate. Okay, so without and this is the way how we evaluate. All right, now for example, you can see this truth table over here. Okay, so if you take the condition, okay, if your input A is 0, input B is 0, and input C is 0, then you can see how it is evaluated. Now you can see why every time 0 is coming where. Now you can see here, whenever a single signal, I told you take it as a multiplication, wherever a single multiplication, in the multiplication also you have seen that if 0 is there any one of the digit, of course the whole answer will become as the 0. So you can see 0 0 1, so 0 into 0 into 1, of course it will be as a 0. So I'm just giving you a trick. All right, now in this row also you can see it is giving 0, this row also, this row also. What is all possibility they have. Now in the last moment they have said that if all inputs, all three input A, input B, input C, okay, if all three input is in a positive, means in a high state, then only the answer will be in the high state. So this all combination you can check, and you can see how the truth table is also increased all possible well. So you can even generate, okay, you can also generate four with four input also, okay, as in some syllabus I have seen there was the regarding that they have taken the the truth table was based on the four input also, even the picture was also that two input and gate, three input and gate, four input and gate, this kind of picture can come. So gate will be same all the time, your input will change, right? All the time your input will change, and then according to that your output will be evaluated. So it is not difficult, follow the same rule and then you can do it. And then again same thing you follow with the another that or gate also. All right, so keep revising, and you try with the four input and gate the truth table. If you know the truth table, drawing the picture is not very difficult, and this is the way how we present it. All right, we can present this is the output, means A into, actually this dot is the symbol of the and, okay, this dot is the symbol of the and you can consider it as the multiplication, so it will be easy. Means of course all the time if you apply some trick, so it is easy for you to recall. Okay, so the next part I will try with another logic gates, and the along with the truth table, so it helps you to. So again you divide, okay, like today you have taken with the two input and three gates you have learned. So first of all 2-3 days you revise this, and then you go further. Once you are perfect in this, then only you go further. Take care and keep